Welcome to our show, Transient Luminous Events, a display of lights above the storm. The sky offers us countless breathtaking phenomena. We are blessed to see vibrant rainbows, sunrises and sunsets, enchanting auroras, stunning cloud formations, eclipses, and dramatic lightning storms. Human beings have watched the sky since the beginning of time, so it is astonishing to find that in our modern age, there are newly discovered occurrences in the sky. Recently, scientists have seen phenomena that they call blue jets and red sprites, along with the nearly invisible elves. Today, we'll take a look at these colorful events. In June 2024, an astronaut aboard the International Space Station captured a photo that seemed to show UFOs or alien spaceships. Alongside the orb-like shapes, subtle hints of bright red flashes appeared in the image. NASA described these colorful streaks as a less understood phenomenon linked to powerful lightning events. The photo actually captured natural phenomena known as blue jets and red sprites, forms of lightning that shoot upward into the sky rather than down toward the earth. The technical term for these events is Transient Luminous Events, or TLEs. TLEs are short-lived electrically induced forms of luminous plasma that occur well above the altitudes of regular lightning and clouds. The European Space Agency, or ESA, has begun tracking lightning storms in an effort to understand blue jets, red sprites, and other TLEs. Although pilots had reported similar sightings earlier, blue jets were first documented in 1994. These optical ejections originate from the electrically active core regions at the tops of thunderstorms but are not directly associated with cloud-to-ground lightning. After emerging from the thundercloud, blue jets typically rise upward in narrow cones of about 15 degrees, fanning out and disappearing at altitudes of 40 to 50 kilometers with a lifespan of just a few tenths of a second. Andreas Mogensen, an astronaut with the European Space Agency, was the first to capture a blue jet on film from above, shooting into space.
One evening, I was sitting in Cupola, and we were flying over India when I saw this gigantic thunderstorm begin. So here you can see a gigantic thundercloud that's lit up by what we would call traditional lightning. So here we have these red sprites. So this is red lightning that's shooting upwards out towards space at the same time that there's traditional white lightning that we know. And as I looked further, I also saw this. So here we have one of these blue jets, so blue lightning, again, shooting up into space. And I actually managed to capture that on film. So in about 4 seconds right here, you'll see this blue lightning. There we go.
As Andreas noted, scientists are very excited about his work and have started to analyze the video footage and data he has collected.
In January 2017, researchers at Denmark's National Space Institute published their analysis of his observations in Geophysical Research Letters. Mogensen was able to capture clear video as the station flew over the Bay of Bengal, and they were amazed by what that video showed. Olivier Chanrion, lead author of the publication, reported that during 160 seconds of video footage, 245 pulsating blue discharges were observed, corresponding to a rate of about 90 per minute. One of the blue jets observed reached 25 miles or 40 kilometers above sea level.
With these observations and records, scientists now have the opportunity to analyze and measure the impact of this phenomena. One of the key focuses is to determine how closely these events are linked to the thunderclouds that overshoot into the stratosphere, injecting greenhouse gases and aerosols. Understanding this process is critical, especially in the context of a changing climate. The red sprite is another type of transient luminous events. These events have been theorized to exist for many centuries, but the first one was caught on camera in 1989 by accident. Scientists at the University of Minnesota had been testing a camera for an upcoming rocket mission. Why do they have such a magical, non-scientific sounding name like red sprites?
SPRITE stands for stratospheric mesospheric perturbations resulting from intense thunderstorm electrification.
Sprites start as a huge ball of red light with tendrils that stream down and turn purple, then blue.
Let's see a few more red sprites in the real world. Under the right conditions, they can be observed from the ground during a lightning storm.
On rare nights with clear visibility over powerful distant thunderstorms, you might be able to see and capture red sprites.
Whoa! I saw that one too.
I saw that one.
You saw that red one?
Yes.
Sprites are large-scale electrical discharges occurring high above thunderstorms in the upper atmosphere.
Bam, there's a sprite. Bam, bam, bam. They come in clusters.
They are massive events. Sometimes 50 kilometers tall by 50 kilometers wide.
Red sprites are visible for only a few milliseconds before they disappear. Although they only appear above lightning storms, they are not actually lightning. While lightning is very hot, red sprites are actually cold. Let's explore how this phenomenon works.
One lightning flash can abruptly change the electric field, triggering a secondary flash in a sort of domino effect. Sprites are also initiated by a large electric field change that occurs during a massive horizontally extensive lightning strike far below. These parent flashes transfer huge amounts of charge and are almost always positive in polarity, meaning that the Earth rapidly gains a net positive charge from the strike. But pools of positive charge near the tops of thunderstorm complexes also change, abruptly gaining negative charge. This suddenly creates a powerful electric field between the tops of thunderstorms and a high concentration of positively charged ions existing 100 kilometers or so up into the lower ionosphere. It's this new imbalance that can initiate a sprite.
Let's move from the cold glow of red sprites to the fleeting brilliance of elves, another extraordinary transient luminous event. Elves appear as large, flattened disks resembling what we might expect a UFO or alien spaceship to look like. Once again, elves are a mysterious and unusual name for scientific phenomena, but the word is actually an acronym.
ELVS stands for emissions of light and very low frequency perturbations due to electromagnetic pulse sources.
ELVs start out as a flash of light that ripples out into a flat disk of glowing red-purple light, kind of like a halo or a huge donut in the sky.
ELVs were recorded for the first time in 1990 by a space shuttle passing over French Guiana. They occur approximately 100 kilometers above the Earth and span about 400 kilometers in width. ELVs are characterized by their red color. Because ELVs are so large and last only a single millisecond, they are extremely difficult to capture on regular video. However, this artist's rendering of ELVs gives an idea of their appearance. First, we see ELVs, which is the rapidly expanding ring, followed by a blue jet. They are truly elusive. As more attention has been given to TLEs, additional discoveries have been made. We now know that there are also gigantic jets, gnomes, pixies, and blue starters. Each of these phenomena is related to thunderclouds and thunderstorms, but has its own unique characteristics. Today, we've explored the captivating world of transient luminous events, or TLEs, including the stunning red sprites, blue jets, and the mysterious ELVs. We learned how these phenomena manifest in the atmosphere, their unique characteristics, and the exciting discoveries scientists are making as they study these incredible occurrences. With each new revelation, our understanding of the sky deepens, revealing the stunning beauty and complexity of our atmosphere. As we continue to explore our universe, may your curiosity be ignited and may you always look up to the skies with wonder.
Vegan is not about us only, it's about all others.
Phenomenal viewers, thank you for your precious presence today.